Hi, I'm Katie.
I'm Rachel.
I'm Ivy. The auditory system is an integral part of the human body. It provides not only our sense of hearing, but balance as well.
This video will provide a basic understanding of both the anatomy and physiology of the three of the four main sections of the auditory system.
The outer, middle, and inner ear, which includes the vestibular system. Let's get started.
The ear may simply look like an oddly shaped object on the sides of our heads, but in reality, it is so much more than that. The outer ear is the first section of the ear that interacts with sound. It consists of the auricle or pinna and the external auditory meatus, also known as the EAM. The outer ear collects and localizes sound waves and transmits them to the eardrum to be processed by the middle and inner ear. The auricle or pinna is the cartilaginous portion on either side of the head. It is responsible for helping localize sound and increases sensitivity to high-frequency sounds of about 3000 Hz. The auricle or pinna contains several landmarks, depressions, which are concave areas, and eminences. The eminences include the helix, the antihelix, the crura of the antihelix, the tragus, the antitragus, and the lobule or earlobe. And the depressions include the scaphoid fossa, the fossa triangularis, also known as the triangular fossa, the intertracheal notch, the Simba concha, and also, finally, the cavum concha. Further in from the auricle is the external auditory meatus, also known as the ear canal. It is where sound waves are transmitted towards the middle ear, leading from the auricle to the tympanic membrane. This structure also warms the air before it reaches the tympanic membrane and secretes earwax, also known as cerumen. Earwax helps clean the canal and protects the ear from foreign material that has entered the canal, such as dirt or small insects. Earwax moves outward from the ear through jaw movements and gland secretion. The external auditory meatus, also known as the ear canal, is partially sheltered by the temporal bone. The lateral 1/3 of the EAM contains sebaceous and cerumen glands that produce earwax. The medial 2/3 of the EAM, which is closer to the tympanic membrane, is surrounded by mastoid air cells, and it is about 2.5 centimeters from the concha.
The membrane can be thought of as the drum skin of the eardrum. This structure transmits vibrations to the ossicles in the middle ear. It is formed of 3 layers. The most lateral layer is made up of the same epithelial tissue as the ear canal. The center layer is made of fibrous tissue for support and strength that also helps transmit the vibrations. The most medial layer is a mucosal layer continuous with the lining of the middle ear. There are several landmarks to the tympanic membrane as well. There is the pars flaccida, which is only made up of the lateral and medial layers, making it the least tense. There is the pars tensa, which is the most tense area of the tympanic membrane. There's also the cone of light, the fibrous annulus, which is a bony ring of tissue where the tympanic membrane attaches to the ear canal. The umbo, which is the point of retraction of the manubrium and the most concave point, and finally, the manubrium of the malleus.
Next, we're going to discuss the middle ear. The middle ear is an air-filled cavity located medial to the tympanic membrane and inside the temporal bone. The tympanic cavity, another name for the middle ear, has a function to convert acoustic energy of sound waves into mechanical energy. It is separated from the external auditory meatus by the tympanic membrane, colloquially known as the eardrum. The tympanic cavity has 2 parts, the tympanic cavity proper and the epitympanic recess, located here, superior to the tympanic membrane and the malleus head. The middle ear carries vibrations from the outer ear to the inner ear by transferring sound waves from the air in the outer ear to the fluids of the inner ear. It's irregular in shape. It's long, narrow, and somewhat ovular. It is lined with a mucous membrane and made up of 6 quote-unquote walls. The superior wall, or the ceiling, contains the tegmen tympani, which is a thin sheath of bone separating the middle ear from the meninges of the brain and parts of the temporal bone. The inferior wall, or the floor, is formed by the tympanic plate of the temporal bone, which separates the jugular fossa, which encases the jugular vein, from the middle ear space. The lateral, or membraneous wall, is formed by the tympanic membrane and the squamous portion of the temporal bone. The medial, or labyrinthian wall, pictured here, separates the middle ear from the inner ear, and it leads to the inner ear space. Landmarks include the oval and the round windows, the promontory of the cochlea, the prominence of the facial nerve canal, the prominence of the lateral semicircular canal, and the tympanic nerve. The posterior, or mastoid wall, pictured here in the back, contains the tympanic adductus, which is the entrance to the tympanic antrum. This connects the tympanic cavity, specifically in the epitympanic recess, to the mastoid air cells. This wall also contains the pyramidal eminence, pictured here, which is located behind the oval window, not pictured, near the prominence of the facial canal, and it houses the stapedius muscle. The anterior, or carotid wall, separates the tympanic cavity from the carotid canal here, which houses the carotid artery. It also has an opening for the pharyngotympanic tube, or the eustachian tube, which functions to equalize air pressure in the middle ear and also to remove debris and mucus from the middle ear. The other landmarks of this wall are the canal for the tensor tympani muscle and the cochlear reform process from which the muscle extends. Finally, the canalis musculotuberi, which is a thin sheet of bone separating the canal of the tensor tympani muscle and the eustachian tube. The ear processes sound through an impedance matching system. This happens due to the size ratio of the tympanic membrane and the oval window, which is about a ratio of 17:1. Since the tympanic membrane is much larger, the ear makes up for potential energy loss when the mechanical energy is focused onto a smaller surface, which is the oval window membrane. The ossicles also play a major role in energy conservation by using a lever action created by the vibrations on the tympanic membrane. This increases the level of pressure that is transmitted to the stapes bone, which in turn presses against the oval window to send mechanical energy into the middle ear. With this system, plus the difference in sizes ratio 17:1, we conserve about 33 decibels SPL of sound. The ossicles are the 3 bones found in the middle ear. They're also the 3 smallest bones in the body. The malleus extends from the upper fibrous portion of the tympanic membrane to the umbo, and the head of the malleus articulates with the incus. The incus articulates with both the malleus and the stapes. Its body lies along the tympanic recess, along with the head of the malleus, and a long limb lies parallel to the handle of the malleus. A short limb is connected to the posterior wall of the tympanic cavity. The lenticular process of the long limb articulates with the stapes, pictured here. The stapes has a head, 2 crura, anterior and posterior, and a base of bone called the footplate that attaches to the oval window membrane. The stapes is the final sending of mechanical energy to the inner ear by movement against the membrane of the oval window that causes fluid displacement in the inner ear. There are also 2 middle ear muscles, the stapedius muscle and the tensor tympani. The stapedius muscle is attached to the posterior wall and is housed by the pyramidal eminence. It connects to the neck and the head of the stapes by the stapedius tendon. The tensor tympani stems from the cochlear reform process on the anterior wall. It connects to the handle of the malleus here and pulls the malleus medially and anteriorly when contracted. The final structures housed in the middle ear are the 6 middle ear ligaments. The superior malleolar ligament extends from the malleus to the tegmen tympani. The lateral malleolar ligament attaches from the neck of the malleus to the bony wall superior to the tympanic membrane. The anterior malleolar ligament extends from the anterior process of the malleus into the anterior wall. The posterior ligament of the incus attaches from the short process of the incus to the posterior wall. The superior ligament of the incus attaches from the head of the incus to the superior wall or tegmen tympani. And finally, the annular ligament attaches from the footplate of the stapes to the oval window.
Hi, Ivy again. For the third part of our ear tour, I'll be talking about the inner ear. Speaking of which, the diagram you see here is of the inner ear isolated from the rest of the ear structure. Now, most people probably recognize the cochlea. It's right here. It looks kind of like a snail shell as well. And they also probably recognize the semicircular canals, which are as follows: the superior semicircular canal, the posterior semicircular canal, and the lateral or horizontal semicircular canal. Of course, the inner ear is a lot more than just a bunch of funky tubes, so we'll definitely get into more detail on that. But before we do that, it should be noted that these semicircular canals are not in fact tubes you could dissect from somebody's head. Instead, what you see here in this diagram are more the shape of the canals within the head. This is as if someone had poured a cast into the canals and then removed the cast from the canals. So again, they won't actually look like this. This is just the shape of the canals. You can't actually remove. We can finally talk about the cochlea. So what we're looking at here is actually a cross-section of the cochlea if you had first uncurled the cochlea and then cut a little wedge out of it. As you can see, the cochlea actually consists of 3 canals: the scala vestibuli, the scala tympani, and then the cochlear duct. The cochlear duct is actually the scala media, so it will be referred to as such. The scala vestibuli and the scala tympani are made of bone, and they contain a fluid called perilymph. Now, perilymph is very important because it allows the mechanical energy from the ossicles to be eventually converted into electrical impulses as they move through the cochlea. However, these electrical impulses would never happen without 2 important parts of the cochlea, which is the basilar membrane and the organ of Corti. The organ of Corti is the most important of all because it's the end sensory organ, and it's also where the hairs are sheared and does send out electrical impulses. However, none of these electrical impulses would be even stimulated without the basilar membrane. Now, the basilar membrane sends out energy to the organ of Corti based on the maximum displacement created by the various frequencies entering. The frequencies, lower frequencies, are going to be at the will be stimulated at the apex, and the higher frequencies will be stimulated at the base of the basilar membrane. But all of them will eventually go through the organ of Corti and thus be turned into electrical impulses. And now to Rachel, who will be telling you more about the vestibular system.